Hello, 7th hour, and welcome to the screencast of how to make measurements with the sound level meter and how to do calculations associated with the sound level meter. So I made a couple of video clips for you regarding the use of the meter as far as making measurements, so we'll check that out here quick.
Alright, this is the decibel meter, and the first thing you'll need to do is turn it on, slide the switch in the upper left corner to on DC, and you should leave the weighting alone on C. That's making it act like a human ear. And then the decibel level down in the bottom, leave that set to the left at first when you're trying to measure how quiet you can get. And I think leave the response on slow. So over here, set this switch to the leftmost setting. Try to see how low you can get the meter to read when you're trying to be as quiet as possible. The next thing to try will be just getting a background level when everybody in the room is talking. So for that, you'll likely need to switch the bottom left setting to the 50 to 100 range in the middle. And again, leave the slow response and C weighting, and try to note with the meter what is sort of the highest reading that you get there. If you want to, you can switch it over to max hold, and at that setting it will record the highest reading and leave that reading on. And the last thing you'll need to do is to try to see how loud you can be as a class, which I'm sure all the surrounding rooms will appreciate. So set the level in the bottom left corner to 80 to 130, and set the response to max hold. Now you can see that when I was moving the switches, that rattled it enough that it registered a level of 151, which isn't right. So just slip it back over to fast and then carefully slide it back over to the max hold setting, and you should be able to get something a little bit higher than 100 decibels. So I'll anxiously await to see what your level.
All right, so once you've got those readings, then we need to figure out a way to convert them into something meaningful. And the human ear is a pretty sensitive instrument, but it has a lot of difficulty distinguishing volume, if you will. And so the lowest threshold for the human ear, the quietest thing you can hear, is the, let's see, minimum intensity. Wow, you get to see me spell in real time here. For the human ear, it's I sub O, and that's 1 times 10 to the negative 12th watts per meter squared. So you're looking at power and area there. So if you can think of the amount of work that's done in a given amount of time, moving your eardrum back and forth, that's kind of what we're talking about with sound intensity. But you're probably more familiar with the idea of a decibel level. And again, that's what you're measuring there. So you saw my background level was right around 63 decibels. So what does that mean in terms of sound intensity? Well, the decibel equation will give us a relationship between these two ideas of sound intensity in watts per meter squared and decibel level. And to get the decibel level, I take 10 times the base 10 log, and then it's the ratio of the intensity of your measured sound, if you will, to call it that, and dividing that by the minimum intensity for the human ear. That's the I sub O that we looked at earlier. So if you have a decibel level of 63 decibels, it's I, the intensity that I'm measuring, divided by I sub O, the minimum threshold that the human ear can hear. I don't want that subscripted. There we go. All right. And so the first thing that I'm going to do is divide both sides by 10, so that gives me 6.3 that. And then if I have 6.3 equals the log of I over I sub O, that maths out to 10 raised to the 6.3 equals I over I sub O. And I know I sub O is 1 times 10 to the negative 12th, so I take 10, raise that to the 6.3, and I'm going to multiply that times 1 times 10 to the negative 12th watts per meter squared. And that'll give me my answer. So go ahead and punch that into the calculator there and see what you get. So when I push that through the calculator, I take that 10 to the 6.3 and then I multiply it by I sub O from the other side in order to get I. So let me change this here. Yeah, we're good. So I get 2 times 10 to the negative 6 watts per meter squared. That's the intensity of that sound. If instead I had a decibel level of 83, well, I can kind of skip the initial steps here because I know that's going to be 10 to the 8.3 equals I over I sub O. If I solve that out for I get 2 times 10 to the negative 4th watts per meter squared. And if I have 113 decibels, that becomes 10 to the 11.3 equals I over I sub O. And I get that the sound intensity associated with 113 decibels is 2 times 10 to the negative 1. So you notice I kind of kept these numbers cleanish. We've got 63, 83, and 113. And if you compare 63 to 83, that's 20 decibels apart. Notice how these numbers compare. And then if we compare 83 to 113, that's 30 decibels apart. And again, notice how these numbers compare. So you kind of see the relationship here when we're talking about a base 10 log scale, how things change when something is 10 decibels louder versus 20 decibels louder versus 30 or 50 decibels louder. And so that's part of what you'll need to see with this equation here.